What if you could tint your windows on demand? You know, block out all that harsh sun and heat with just a little bit of light, and then, poof, make them crystal clear again with a puff of air. Well, today we're going to break down a brand new material that does exactly that. And honestly, it could completely change how we think about our homes and cars.
Okay, so let's dive right in. What you're looking at here is a liquid that starts off as this transparent yellow, but then you hit it with some UV light and it transforms into this deep, solid black. And the craziest part? With just a little bit of air, it flips right back to being clear. So what in the world is going on here? How is that even possible?
Now, you're probably thinking the secret ingredient here has to be some rare, super expensive, high-tech compound, right? But the answer is actually hiding in plain sight. It's in stuff you probably use every single day.
Yep, get this. The active material is titanium dioxide, or TiO₂. It's everywhere. It's abundant, it's non-toxic, and it's totally safe for the environment. In fact, it's the very same stuff that gives white paint that brilliant color. And, you guessed it, provides the powerful UV blocking protection in your sunscreen. So, why is this such a huge deal? Well, current smart window tech often uses something called tungsten oxide. The problem? Tungsten is pretty rare and super expensive. The EU even calls it a critical metal, meaning it's risky to rely on. But TiO₂, it's one of the most common materials on Earth. This isn't just a tiny step forward. It's a complete game changer that could make this tech affordable for everybody. Okay, wait a minute. If titanium dioxide is in our paint and sunscreen, why doesn't my face turn black in the sun? That is a fantastic question. And it turns out the material itself isn't the whole story. The real secret isn't what it is, but how big it is. And you know, the science backs this up. The original research paper puts it plainly. In its normal, everyday form, pure titanium dioxide shows almost no photochronicity. That's just the fancy word for changing color with light. So something else has to be going on here. And this is where the magic happens. It's all about the nanoscale. Scientists figured out how to create these tiny, crystalline nanoparticles of TiO₂ that are just 4 nanometers across. To give you some perspective, a single human hair is about 80,000 nanometers wide. I mean, that is ridiculously small. And when you shrink stuff down that much, you can unlock totally new properties. All right, so we've got these incredibly tiny particles. But how do they create such a dramatic, powerful effect? Well, it all comes down to some really clever chemistry that kicks in the moment light hits them. Let's break it down. First, UV light zaps the nanoparticles and energizes their electrons, knocking them loose. Second, the liquid they're floating in this case butanol, cleverly grabs the holes those electrons leave behind, which lets the electrons roam free. Third, a few of these electrons get trapped on titanium atoms, and that's what makes the material absorb visible light and turn black. And fourth, this is the really cool part. Most of the electrons stay free, forming what's called a plasmon cloud. You can think of it like a collective shield of electrons that is amazing at blocking infrared light, which is the heat you feel from the sun. Now, check out the data, because it really shows you just how effective this is. On this graph, you can see here at the start, the liquid lets almost all the light pass right through. But just watch what happens over 2 hours of UV exposure. The line just plummets. The transmittance drops to almost zero. It becomes a near-perfect light blocker. But now, look at the same graph right here. They inject a little bit of air into the liquid. The oxygen in the air immediately reacts with all those free electrons we were talking about, and boom. Just like that, the material shoots right back up to its clear, super transparent state. It's completely reversible. And here's the real kicker. This isn't some one-time trick. You can see they cycled it back and forth from dark to clear multiple times, and the performance barely changed at all. That kind of stability is absolutely crucial for any product you'd want to put in a window frame for years and years. So, to sum it up, we've basically got 2 different things happening at once. The trapped electrons, they're blocking the visible light, making the window look dark. And that cloud of free electrons, that's what's stopping the infrared light, blocking the heat. It's this dual action system that makes it so incredibly powerful for controlling both light and temperature. This is some seriously cool science, right? But what does it all mean for us, for the real world? Well, this discovery isn't just about a neat new material. It's about finding ways to build a much more efficient and sustainable planet. So, the official name for this kind of technology is a photochromic material. It's basically any substance that can change its color or how see-through it is when you shine light on it and then change back. You've probably seen it in those transition lenses for glasses, but this just takes that whole idea to a completely new level. And the potential impact this could have, it's staggering. According to the research, if we develop highly adaptive smart windows like these, we could save about, get this, 4.5% of our total annual energy consumption. That is a massive number. We're talking about huge cuts to our heating and AC bills and a major reduction in our carbon footprint. So here's the big takeaway. By taking an everyday, inexpensive material and just shrinking it down to the nanoscale, we've unlocked a way to create a powerful smart liquid. This could pave the way for affordable, energy-saving windows in our homes, our offices, our cars, letting us control our environment with the flip of a switch, or maybe just the light of the sun.
And that really just leaves us with one fascinating thought. We unlocked this incredible property just by shrinking down a material we see every day. It makes you wonder, right? What other superpowers are hiding in the common stuff all around us, just waiting to be discovered at the nanoscale?